Hi everybody, welcome back to part 2 of our Precalculus section 6.4, partial fraction decomposition. This is Mr. Gallagher and we are going to do one more example, and one's a little bit more complicated than the other two examples that we've looked at so far. So let's get started. This is number 3 and I'm going to look at negative x squared minus 3x minus 8 over x cubed plus 4x squared plus 4x. And this one is a little bit more complicated example than we saw before. So again, I want to break these down into simpler fractions, simpler rational expressions. But in order to do that, I need to determine what the factors of this LCD are. So let's start by going and factoring out this denominator. So I'm going to factor that out by saying this is what x times, if I pull out an x first, I'm going to be left with x squared plus 4x plus 4, right? And then if I factor that, that's going to be x plus 2 times x plus 2. Or another way of writing that would be x times x plus 2 squared, right? That is my LCD, my least common denominator. So I'm going to break this down into, again, smaller rational expressions, but this one's a little bit different because I've got a repeated factor. I've got an x plus 2 squared. So when I start breaking this down, I know one of my fractions is going to be an x, so I'll put that a over x. And then my next one, my denominator is going to be, well, obviously I have an x plus 2 in there, and that'll be what's underneath b. But now, if it was just those two, then my LCD would be x times x plus 2. But I've got an x plus 2 squared, so there obviously had to be a third term that had an x plus 2 squared, or a fraction with x plus 2 in there twice. Otherwise, I wouldn't have that x plus 2 quantity squared. So that's going to be a third fraction, and I'm going to put a c for the numerator on that one. So now for this one, I'm going to have to calculate or figure out what a, b, and c are. So let's rewrite this fraction now this whole equation with my proper LCDs everywhere. So this is going to be negative x squared minus 3x minus 8 over, and let's just write this as the LCD, x times x plus 2 quantity squared, right? And now my three other fractions that I'm going to rewrite them all using my LCD. So this is x times x plus 2 quantity squared, x times x plus 2 quantity squared, x times x plus 2 quantity squared. So how does that change my numerators? Well, a just had an x in the denominator, but now it has an x times x plus 2 squared, so I'm going to have to multiply the top by x plus 2 squared, right? Again, to keep the fractions the same. The next one with b, in the denominator, I put an x and another x plus 2, so I'm going to have to put an x and an x plus 2 in this one, again, so that they're now all equivalent. And then c had an x plus 2 squared. I put an x in the denominator, so I'm going to have to put an x in the numerator now. So all of these are equivalent fractions from what I had. So now remember, recall that if we now have an equation where all the denominators are the same, then all I have to worry about now are these numerators. So I'm just going to rewrite the equation using just my numerators. So what's that going to be? Negative x squared minus 3x minus 8 is equal to a, and that's x plus 2 quantity squared, and that's going to be b x times x plus 2, right? And that's just going to be cx. So there's my equation rewritten with just the numerators. Now I have to choose a method to solve for a, b, and c. So I need to choose a method. Now remember, we looked at two different methods in the last video. The first one we could do would be something called a system of equations, right? System of equations. And that would be where I would multiply all of these out, right? And I would look at the x squared terms. They all add to where a, b, and c that had x squareds, that would have to equal -1. And the ax and the bx and the cx would have to equal -3. And the ones that had the constant terms, those would equal -8. I would get 3 equations with 3 unknowns, and then I could solve. Well, 3 equations and 3 unknowns, that's a little bit of a pain in the neck to solve, right? The other method that we could use to solve for A, B, and C would be to choose smart values for x, right? And when I say by choosing smart values for x, I'm going to choose values of x that's going to eliminate some of my a's and b's and possibly c's so that I can solve just for one of the variables. And I could do that a few different ways, and that becomes a lot easier, and I can solve for my a, b, and c, and then I'll have my partial fraction decomposition. So I'm going to do that one. I'm going to choose method 2, where I'm going to choose different values for x. So the first value I'm going to choose for x is, well, remember, when I choose, I'm going to have to look to see something that would help eliminate some of these terms right up here. So the first easy one is I'm going to choose x equals 0. Right? So if I choose x equals 0 and I plug in 0 for x, that should hopefully eliminate, looks like it's going to eliminate the b and the c term, right? Because with multiply times 0, I'm going to get 0. So what happens? So I plug in x equals 0. Well, negative x squared, when x is 0, it's going to be 0. Minus 3 times 0 is 0. And then minus 8 equals a times, well, 0 plus 2 is 2 squared, right? Because I got this 0 plus 2 quantity squared, plus b times 0 times 2, and then plus c times 0. Well, what happens here is this term cancels out and this term cancels out. So as a result, I'm just going to get negative 8 is equal to 4a, right? And if negative 8 equals 4a, then that means that a has to equal negative 2. So if a equals negative 2, there's one of my values. I found a equals negative 2. Let's choose another value for x. Well, up here, I've got a bunch of x plus 2's. So I know if I chose x equals negative 2, that's also going to eliminate some of my factors, right? Because negative 2 plus 2 is going to make some other values 0. So let's try plugging x equals negative 2 in and find out what happens. Well, again, back in my original equation, which is up here, that's what I'm going to be solving for. So I'm going to plug in negative 2. So I'm going to get negative 2 squared is 4 times negative 1 is negative 4, right? And then negative 3 times negative 2 is positive 6. And then negative 8. Again, I'm plugging in x equals negative 2. And then what's that going to be? That's going to be a times 0 squared, right? Because negative 2 plus 2, plus b times negative 2 times negative 2 plus 2 is 0. It's going to eliminate that. And then plus, and this is going to be negative 2 times c, right? Because negative 2x, or c times x, and c is, x is negative 2. I get that. So what happens here? This is going to eliminate this term and this term because of my zeros. And I'm going to be left with, I have negative 4 plus 6 minus 8. That's negative 6 equals negative 2c. So as a result, I know c is going to be equal to 3. So there is another term I've got. I've got a and I've got c. Now at this point, there's not a different value I could plug in for x because I've got a and I've got c, but there's not another one that I could plug in just to get b by itself. So what I'm going to do here is I'm going to choose another value for x, and I'm not going to try to get b by itself, but I'm going to use my a and my c values as well. So let's do a value that's going to be really easy to use for x. I'm going to try x equals 1 because that's an easy one to do. But then I'm also going to use what else I know. I know that a is equal to negative 2, and I know that c is equal to 3. I've already solved for those. And now if I just plug all those in, I can eliminate all the other variables and just be left with b, and I can solve for b. So what happens when I plug in x equals 1? Well, again, back into my original equation here, I'm going to plug in x equals 1, and I'm going to get negative 1 times 1 squared, so I get negative 1, and then negative 3 times 1 is negative 3, and then minus 8, and that is going to be equal to, a is negative 2, so negative 2, and then 2 plus 1 is 3, so 3 squared, right? Because I plugged in x equals 1. And then for the b term, I'm going to get b and x equals 1. And then 2 plus 1 is 3, so b times 1 times 3. And then c times 1, which is, or c times times, well, C I already know is 3. Let me erase that. C is 3. And then times 1. So that's going to be 3. So now what happens when I multiply this out? I got -1, -3, and -8 is -12. And that's going to be equal to -2 times 9 is -18. And then I've got plus 3b, right? And then I've got plus 3. So that's -12, and then -18, and that's positive 3 is -15, plus 3b. I'm going to add the 15 to the other side, and I get 3 is equal to 3b, which must mean that b is equal to 1. So there is my third value. So now I have everything that I need. I've got my a, and I've got my b, and I've got my c. So my original problem, which you remember was negative x squared minus 3x minus 8 over, and it was x cubed plus 4x squared plus 4x equals, and I broke it down into my 3 fractions that were x plus 2, and x plus 2 quantity squared. What is a? Well, I know a is -2. And what is b? I know b is 1. And what is c? I know c is 3. And this is my answer, my partial fraction decomposition. So again, I broke it up and I solved for a, b, and c. That one was a little more complex because we had 3 terms and we had a repeated factor of x plus 2 in my second one. So that's it. So here's the assignment for this week. The assignment for this week is on page 402. And it is numbers 1, 3, 5, 13, and 15. So just 5 problems. And you can go ahead and do those problems, take a picture, and submit them to the assignments page. Just one note, please make sure, we assigned odd problems so that you can check your answers in the back, but please realize for you to get credit for this homework assignment, you're really going to need to make sure that you show your work. If you just copy down the answers and upload them, you're not going to get credit for the homework assignment. So please make sure, obviously there's a lot of calculations that go on with each individual problem, as we've seen through all the different examples here. Make sure we post these notes on eCampus as well. But and then make sure you work out each of these 5 problems that we have here on page 402 and submit them to the assignment for this particular section. And this is this week's assignment. Thank you very much. I hope that worked out well for you. And again, if you have any questions, please don't hesitate to email your teacher or to post the messages on the discussion board. Thank you very much. Take care.